Good morning, everybody. This is Eureka John, and you are on Eureka Street Crypto Hub. This is my morning show, aka video blog, where I talk about crypto daily, and I just basically just my video blog. That's it. And this is my journey in crypto and everything that I'm learning, and I use this as my discipline to make sure that I at least read something and learn something new every single day, so I have some content in the morning to talk about. I'm up every single morning doing this show, talking about something new that I have learned from the day before, or if I'm up early enough, from the very same morning. But yeah, this is, I could be wrong, I could be right. This is just my journey, and it's not financial advice, and I'm not your teacher and all that stuff, you know. Just because I might talk about a coin doesn't mean that I love that coin. I'm just curious, and inquiring minds want to know. And yeah, that's the whole point of this show. So yeah, and then hopefully you can jump on this journey with me and you can learn some stuff. Give me a thumbs up on the YouTube or the BitChute or Odyssey thing. Give me some comments. Let me know what you want me to take a look at as well. I've covered some things that people in the audience have said, hey, you know, take a look at this or that, or can you write, for instance, can you write an article about passing on crypto after you die and stuff like that. So that's, you know, those types of topics are always fun to jump on. And I had somebody ask me to take a look at Polkamine for a hash token, and I will end up taking a look at that here in the future too, because it sounds pretty cool as kind of a comparative token to the BTCST token and that the Mars protocol token. I can't remember what it's called, but it's some kind of long drawn out number. Anyway, yeah, so let's go over here. We'll take a look at the CoinGecko and see what is up. All right, so let me go over here and let me refresh this page. Man, today's Father's Day. Don't forget to thank your father for helping to bring you into this world, for being yeah. Anyway, I won't go into detail about that, but yeah, so today's Father's Day, and I have, you know, two little ones, and then I have, you know, an older one, and I just, the little ones, for them, it's like a national holiday. They wanted to wake me up and do breakfast and all that, and I get it, and I understand, and I love that, but I want to go skateboarding. This is my day to have a little break. So me and a bunch of my old skater homies, we're going to go down to the San Marcos skate park, and we're going to skate. And I'm up at 6:23 in the morning, and as soon as I finish this show, I'm going to run and go do that, and then I'm going to get myself and treat myself, because there's an outlet mall over there at the San Marcos outlet mall, and go to the Vans store and get myself another new pair of Vans Ultra Cush shoes, because those really help when I'm skating at 45 years old and I have to run out of a grind on a very tall bowl or something like that, and my back is just ain't having it nowadays. So those Ultra Cush soles really help. Then I'll come home and greet the kids and come through the door and have them shower me with praise and all that stuff, because, you know, I'll take it, man. I'll take it while I can get it. You know, they're little, so they still like that. My oldest one, yeah, you know, happy Father's Day, and that's great. I love her, and she loves me, and we know we love each other. But yeah, you know, it's not quite the same when she was 5. That was amazing. So no offense if you're listening, but anyway, so let's see here. So Bitcoin 34,107.84, Ethereum 2,099.27, Tether $1, Binance Coin 322.16. I just heard somebody the other day talking about Binance rug pulls and stuff like that, and it got me thinking about rug pulls. And a lot of people don't know what rug pulls are, and I didn't know what rug pulls are for a while either. Rug pulls are whenever you have a new project come about and everybody's jumping into it, and they think it's whatever project it is, whatever finance project, you know, you get 1,000% APY and all that stuff, and everybody jumps into it, and then suddenly all the main people, the whales, the developers, and everybody just decides, oh my gosh, look at all this money we have. Let's not work on this project anymore, take our earnings and run. and that's a rug pull. You got the rug pulled out from under you. You are left holding the bag. And who got involved in a rug pull? None less than Mark Cuban, the owner of the Dallas Mavericks, and on the Shark Tank, and a billionaire or whatever he is. So even in the volatile world of cryptocurrencies, things rarely go south as fast as they did with Titan token. Wednesday afternoon, the cryptocurrency was trading for $65 as of 11 a.m. Eastern Time. It was going for 0.00000 whatever 24. It's terrible. So he got rugged. So even extremely smart billionaire investors can get rugged too. Cryptocurrency is impartial to who you are or what type of clout or money you have. It will rug pull you. So you have to do your homework. You're forced to do your homework. You can't just waltz in here with a bunch of money. Here's their website, Iron Titanium token or whatever, a multi-chain partial collateralized stable coin or whatever, they're throwing out the buzzwords. And notice it's on Binance Smart Chain and Polygon. And Binance is just like rampant right now with rug pull type of projects, so watch out. And that's why I took a look over here when I hit Binance Coin. It reminded me to talk about it. Watch out for rug pulls. There's a billion of these little token projects that are going to offer you 1,000 APY and all that crap. Let's take a quick look here at the Titanium token. Hold on. So Iron Titanium token. And I don't know who turned this billionaire onto this project, because I'd never heard of it before this, but not saying that I know everything. But so here it says, Iron suffered from a bank run, aka rug pull, and is now urging users to withdraw liquidity from all pools. Please proceed with caution. And then you can go to the official Twitter page and probably see everybody cussing them out and stuff like that if they haven't blocked the comments. But let's look at the 30-day chart here. And it's not an old project. So, all-time high, it suddenly shot up to $64.19. Is that because of Mark Cuban suddenly dumping a bunch of money in there? And maybe they're like, oh, whoa, we got a bunch of money. And then suddenly all the developers are like, we out of here, So, bam, damn, too bad, womp womp, somebody got rug pulled. So watch out for that type of stuff. Look for a project's history. Maybe look for a gradual increase instead of a sudden spike and surge in price. Because with that surge in price, unless you're trying to play that game of trying to time these spikes from these low cap altcoin gems, as they call them, don't play that game. Look for fundamentals and buy into something long term, dollar cost average. Try to be as safe as you can. The cryptocurrency world already is the Wild West as it is. I mean, seriously, man. Like, I don't know. But he's got money to waste, and a lot of people do. I don't, so I steer clear of this type of stuff. Just watch out, and watch out on the Binance Smart Chain. Binance, I can't get on the Binance exchange. I can through a VPN, but I can't really bring fiat onto there without KYC, and I can't get through KYC because I'm from Texas. So I don't really have to worry too much about it unless I really go trying hard to dig through the Binance platform to find these things. But they're on Ethereum as well, and as you can see from the website, it's on Polygon and Matic, and I don't know how he ended up approaching this project, but just be careful, man. So let's go back over here to the main charts, and let's see what else we have going on here. So Cardano, $1.34. Dogecoin, man, it's sinking back down to where I wonder when it's going to start sinking way low in the rankings again. I don't mind. Speaking of Dogecoin, I saw an interesting tweet here. Hold on. Okay, this one right here. That's the Doge car.
Really close there.
Bam.
For Mills in the 5. Very lucky to miss. We talk a lot.
Look at that. Tires off passing that finish line.
I was going to say, we talk a lot about the racetrack and keep it up and how great it looks. Remember, 10 years since a NASCAR race.
Yeah, no comment needed. Charles Hoskinson actually posted something.
Right, really close there.
Dogecoin crossing that finish line sideways.
Very lucky to miss. We talk a lot.
Dogecoin makes no sense, you know.
I was going to say, we talk a lot about the racetrack.
Anyway, so there's that. Then Bitcoin and Ethereum have been sideways, but look at this here. This video was sponsored on WeChat by Bitcoin miners who got their operations shut down in China. This is another topic now. The lesson from the internet is anything that China bans, invest in it. So I'm looking at this, and I'm looking at all these miners being shut down, bam, 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 all these mining operations. So China is actually cracking down on mining, and it's not just, it's not just a bunch of bark. They're actually biting this time. So here, Bitcoin hash rate transition, in which more than 50% of its industrial base, representing $15 to $20 billion in annual revenue, leaves China and becomes globally dispersed while Bitcoin continues to maintain 100% uptime, is nothing short of a modern marvel. That's absolutely true. I mean, that is a lot of power to have centralized in one place, and a lot of people had concerns that China was going to be dominating the Bitcoin market and that anything that they could do could affect the Bitcoin price, and all the Bitcoin power is centralized in one place. So if everybody starts buying into Bitcoin, they're basically giving China power. I don't know if that's true or not, but all this mining power being switched off in China basically gives the power of all the mining to all the other nodes around the world. And right now may be a good time to start a Bitcoin node if you're not in China. So you can take some of that hash power, and I don't know the dynamics of what this does, but what does this do to the difficulty of the hashing algorithm? And speaking of which, I'll talk about hashing algorithm here. Hold on one second. Name another industry that could carry out an infrastructural transition that seamlessly within a year. It's just what? The revenue figures are for the entire mining network. Oops, okay, whatever. A wonderful demonstration of also how Bitcoin doesn't need any country's support. Exactly. Bitcoin is decentralized. It does not need any one country. It doesn't need El Salvador. It doesn't need the United States. It is self-sovereign. The country needs the Bitcoin industry. Those who destroy their own industry will pay the price. All this without central party coordinating. The hive mind is looking for the best option. Yeah. What this shows is that a government was able to shut down Bitcoin mining, which is a weakness. If it was proof of stake, then it would be near impossible to find the nodes, as they can be as small as a mini PC and undetectable on electricity bills and /use. That's a point, but I don't really see that as a weakness. All it does is just basically displace the mining power to other places and other nodes around the world. So it doesn't show how a government can shut down. I mean, yeah, a government can shut down a mining operation or some mining operations. It can't shut down Bitcoin mining. So all that does is just give more power to the other nodes around the rest of the world and decentralizes it in that way. So how is it working? Bitcoin is working uninterrupted. Exactly. Bitcoin is continuing to pump out those blocks. Just like clockwork. Exactly, clockwork. Not like clockwork, it is clockwork. It pumps out those blocks, and it has not stopped just because China's over here throwing a temper tantrum like a 2-year-old. So let's see here. How's it a weakness? Bitcoin is working uninterrupted now. It is less secure now. I don't think so. How so? What evil plan can be unleashed over the next month as miners disperse? I'm not sure we can compare a communist country to a democracy. It should be near 100% resilient no matter what the government structure, though. Being dependent on all the political goodwill is not desirable. I take your point, but given game theory, Bitcoin cannot be defeated. Okay. Governance can also shut down exchanges. That's necessary to buy the coins required for participating in proof of stake, and that is true too. I agree it's impossible to detect a proof of stake validator under operation. But that's not because it's not tethered to any physical resource in the world. Now, we need to get away from this whole proof of stake, proof of work tribalism. You know, I think they're both interesting and effective ways of mining cryptocurrency, and they both have their pros and their cons. The whole argument that proof of work uses too much energy and green energy is just complete BS. And there are plenty of alternative ways to get the energy for the Bitcoin proof of mining. And when you look at all these other industries, especially the military and industrial complex and the entire banking institution, both of those use exponentially more energy than Bitcoin ever will. So you got it backwards. Bitcoin showed resilience in the face of a mining ban of 50% of hash rate. The most dangerous was on the most damage was on PR and narrative front, as it usually goes. Yeah, okay. So anytime Bitcoin has a weakness, it just evolves and adapts as the apex predator it is. What you see as weakness is merely a pending resilience upgrade as all actors in the network reflect and modify around new barriers. I wouldn't say predator is a weird metaphor for Bitcoin, because it's not a predator. It is just basically the light. So, all right, so what's offensive? This is a government will always be able to shut down any individual computer. It was not able to shut down Bitcoin mining. Okay, all right. So anyway, enough on that. Now, I want to take a look over here at SHA-256. I'm working on a video for Komodo, because I do these educational videos on Komodo and for the Komodo blockchain. And I like the Komodo blockchain and the Komodo project, and I want to try to help them out as much as possible. They're not paying me, so I'm not shilling anything. To me, I'm kind of going through this Komodo Academy learning. And so what better way to learn than to try to prepare yourself to make a video in which to convey that content. So that's exactly what I'm doing here. I'm making these videos, and it's going to be going on the Komodo Academy website, and there's just tons of articles. There's a wealth of information, but I'm going over this one. What is a hashing algorithm? So speaking of Bitcoin mining and hashing algorithms, this article is written by Dalton Rhodes of the Komodo team. Basically, a hashing algorithm is a function that converts any input data into a fixed length output known as a hash. It doesn't matter whether the input is a single letter, a page from a novel, or an entire set of encyclopedias. So a hashing algorithm could represent all the pages of this book, or it could just represent cat, and they both end up in SHA-256 as 64 characters of hexadecimal numbers. Each input will produce a unique output expressed as an alphanumeric string of uniform length. Let me just show you a quick visual over here. SHA-256 generator right here. SHA-256 is the hashing algorithm for Bitcoin. Hold on one second. Before I get to this, let me go down here. How's it used in Bitcoin? So it's used for data integrity, increased performance, password security. There's some various hashing algorithms. Hashing algorithms and blockchain technology. Hashing algorithms are particularly helpful when applied to blockchain technology. Public key hashing. Blockchain networks often use addresses rather than public keys. So the public key itself is kind of long. So when you have a wallet and you have a private key and a public key, the private key is the one you keep in order to access your wallet, and the public key is the one that you give away to the public so they can send you cryptocurrency and Bitcoin and stuff like that. But the public key itself is pretty long. So in order to truncate that, to shorten it up, hashing algorithms create a hash of that, which is 64 characters. And so that is the address. That is the hash address. So public keys are run through a hashing algorithm. The output, called a public key hash, is then used to create an address, which helps to improve the private. What did I just do? I just clicked on a broken link here. Sorry, this article doesn't link to anything. Okay. Where was I? Public keys are run through a hashing algorithm. The output, called a public key hash, is then used to create an address, and it helps to improve private key security on public networks. So it helps to improve your private keys. It provides a shorter, more user-friendly public identifier for sending and receiving transactions. So it makes sending transactions easier. And then another use of the hash algorithm is before one person is able to send funds to another, the data for that particular transaction is run through a hashing algorithm. The output becomes one component of the digital signature, which the sender must attach to for the transaction to be approved to the peer-to-peer network. So it provides this digital signature saying that something has been sent and received. The recipient of the transaction can then use this output to verify that the transaction data has not been altered and that the accompanying digital signature is authentic. So I'll show you, I'll follow up on this for a second. Just hold on to that idea. And then a Merkle tree is a data structure that uses a hashing algorithm to take a large body of data and derive a single output called the Merkle root. This single 64 character alphanumeric root string acts as an electronic fingerprint for an entire body of data using the Merkle root. So think about this. You have an entire database full of like billions of items, okay? And then you can break that down and put that into a 64-bit hash. And then you can have that as the fingerprint for that database. And then if you need to copy on distributed ledger all that data to a bunch of other different databases, in order to make sure that they are all the same, all you have to do is compare the fingerprint, the hash that represents all the data on that database. So if even one character of data is changed on that database, then the entire hash algorithm, the hash changes. So if it changes, then you know that the data on that database is not the same. And then cryptocurrency mining, where we were at in the beginning when China shut off the mining. Where proof-of-stake blockchains rely on staking to validate new blocks and secure the network, proof-of-work blockchains rely on cryptocurrency mining. Hashing algorithms are a major component of mining. Stated very simply, miners compete to mine new blocks by running blockchain data through a specific hashing algorithm over and over until they produce a hash that is less than or equal to a predetermined target. Once a miner finds a satisfactory block hash, they broadcast it to the network, and then if consensus, all the databases and nodes around the world have the same output, then it's considered a valid transaction, and then the node that finds that hash is the one that wins the block. I don't know where they get this target, the predetermined target. That's above my pay grade. So, either way, these miners, they have to brute force run these hashing algorithms till they find the hash that is closest or at this predetermined target that needs to be hit. And like I said, once again, it's above my pay grade. I don't know where this predetermined target is or how it's generated, so anyway, let's go over here now that we know this stuff of what a hash is, now it's used. Now let's look at here. Cat. Okay, so we'll just hash this. I created that 64 key hash. That's SHA-256. There's a bunch of different ones that come out with different length ones, but this is the most widely used one. So cat. All right, so now we will change this to capital C-A-T, and then we'll hash that. What? Hold on. Yeah, see how that completely changed? This is lowercase cat, and that's uppercase cat. They absolutely look nothing alike. Now, let's say we go over here, and you can do this for files too. So check this out. All right, so you have a file. Let's go into here. We'll choose a file. I'll go into my photos or whatever. I'll pick this photo of me wearing a Barry Manilow t-shirt. All right, so it's a PNG file. That's the hash that represents that PNG file. Barry Manilow, John wearing a Barry Manilow t-shirt. All right, so let's go in and we'll browse. Okay, hold on, real quick. So now the last 7 digits are 7C91 for that. Okay, 7C91. So let's go in here and we'll pick this picture of skateboarders here. And so that one is 2948. That's the hash that generates that. The last 4 digits are 2948. So we'll go back and then we'll browse and we'll go back to me wearing the Barry Manilow t-shirt. And then it comes back and it hashes once again as 7C91. So it comes up with the exact same characters. So no matter what size of picture, I mean, I could use a huge video file or whatever, and it will, if it is the same item, it will always come up with the same hashing algorithm. And for those of you who are not familiar, I mean, I will even go all the way back to what is an algorithm. So let's just say definition of, I'm not going to assume anything, like I haven't assumed what people know what scalability is and all this. I mean, sometimes you just even if you think you know the word, go back to just the definition of a word and just look at what is it, because definitions of things can be changed over time or by context or circumstance or whatever. It's a set of instructions for solving a problem or accomplishing a task. One common example of an algorithm is a recipe, which consists of specific instructions for preparing a dish or a meal. Every computerized device uses algorithms to perform its functions. So, whenever the computer is going through and using my Barry Manilow t-shirt photo right here, and it is providing a hashing algorithm, it looks at that Barry Manilow t-shirt, and then it goes through a set of a bunch of equations, and it runs through a specific sequence of equations in order to get this number for that Barry Manilow t-shirt. And if anything, even one pixel of that Barry Manilow t-shirt were to change, then this entire hashing algorithm would change completely. Even one pixel. So that's kind of how the concept of NFTs have come about as well, to verify the authenticity of a photo. It creates a hash for a specific photo, and then that becomes an NFT. So it has to be the exact photo, even down to the pixel, as it runs through the hashing algorithm. Because when one pixel is changed, I mean, that's a hexadecimal number. Those are 6 digits in that hexadecimal number per pixel. So if one of those changes, the entire thing changes the entire algorithm. So yeah, anyway, so that's that. I did not think I'd be spending 25 minutes and 40 seconds talking about hashing algorithms today, but I mean, I guess I broke off to that, but it all kind of flowed organically, I guess. So as you can see here, there's various types of hashing algorithms. Hashing algorithms are used for password security, data integrity, as I said, increased performance. This can be used for DNA and RNA sequencing, which is really important for a lot of the disease research we have right now for like cancer and stuff like that. And I don't know where your stance is on the Rona, but yeah, it could be used to either help or discredit everything that is going on with that. The DNA, RNA sequencing, it takes a long time to deal with billions of entries in DNA and RNA sequencing. So hash algorithms can represent large amounts of data in order to be able to do sequencing of DNA. And I can't even begin to go in and try to pretend that I understand anything that goes on in that field of science. But as a result, it's possible to speed up the treatment discovery process for medical conditions and diseases such as Parkinson's and cancer and Alzheimer's and things like that. Data integrity, yes, it's an important use case for hashing. Outputs are an easy way to ensure that the data hasn't been tampered with or edited at any point in time. When saving a file, for example, it's possible to use a hashing algorithm to produce a hash of that document, just like I showed you with the photo. If you access that file again later on, you can run the file through the same hashing algorithm. When looking at the output, it only takes a split second to compare them. Now, keep this in mind with these IDs that they're trying to push out on us. And there's an argument, well, if we have this ID that shows our sensitive health information, then everybody, including the bartender, will know exactly what our health information is. That's absolutely not true, and I'm not trying to advocate for these vaccine passports because I hate them. But your data, your medical data, is hashed, and it's created as a hashing algorithm. And then whenever somebody is trying to cross-check whether or not you have had certain medical procedures or medicines or things like that taken, all it does is compare hashes to give you a green light or a red light. So it's kind of how that works. I mean, it's super oversimplification, but you get the gist. Your information is what being shown on your passport. It is just the hash of the information, so nobody can see what you're holding. But I mean, obviously they know the outcome of it once they see the green light. So but say for instance a bartender needs to know if you're 21 or not. All they see is a green light. They don't know how old you are. They just know that you're over 21. So they don't see your birth date or anything like that. So let's take a look here. Here's some other ones. So what is a hashing algorithm here with a question mark? And that gives you that. And then what is a hashing algorithm with no question mark? It gives you something different. We went through that. There's different types. There's Blake, message direct, race integrity primitives, evaluation, message digest. It's a mouthful. And secure hashing algorithm. So Blake gives you this. Some examples include digital signature algorithms, message authentication, integrity protection mechanisms for public key infrastructure, secure communications protocol, cloud storage, intrusion detection, forensic suites, and version control systems. So that's what Blake is used for. So it seems to be used more in the commercial and law enforcement space. Message digest algorithm. This one's a short one. It was published in 1992 and is mainly used to verify that text or files have been unaltered by using checksums. And the checksum is kind of what I showed you with the file. MD5 is no longer used because it can be cracked with relative ease given the strength of modern computers. So look at how short this algorithm output is. So the shorter it is, generally the less secure it is. So this one's a bit longer, as you can see in the Blake one. And then here's the race integrity primitives evaluation message digest. This one is used for a couple different kind of Bitcoin transactions: pay to pub key hash and pay to script hash. Pay to script hash is one used for multi-sig, and here's the output for that. It's a bit longer than the MD5, but not much. But it's still, this is used in conjunction with SHA-256 for the multi-sig transactions. So that one uses both of these. So it has the security of the SHA-256, and then it uses this as well. So so it can use a shorter hash algorithm. Then here's the SHA-256, and there's not just SHA-256, but there's several versions of this. It's a family of 4: SHA-0, SHA-1, SHA-2, SHA-3. So yeah, although SHA-3 offers the highest level of security, SHA-2 is more widely used today. So anyway, it kind of gives you the basic rundown of hashing algorithms and stuff like that. So yeah. Interesting stuff. I can't link this article yet in the description because it has to come out on the Komodo Academy. I think it is on the Komodo Academy somewhere right now, but yeah, it just kind of gives you a little snippet of what I'm working on. So anyway, I will go ahead and get on down to the skate park and meet up with the dudes so I can get the skateboarding in early in the morning and get back in with the kids. Appreciate your dad, and Dad, if you're watching, I appreciate you as well, and thank you for bringing me into this world and for everything that you've done to me and all my shenanigans that I've put you through in life on the way up to the age I am now. So yeah, happy Father's Day, and to my kids out there, thank you for being my kid. All right. All right, and I love you all. All right, so I will talk to you guys later. LFC X11. I'm sorry. We're just saying hi and bye. We're high-fiving each other. So welcome to the show. Let me gift you a little something, and thanks for jumping on. Maybe next time we can catch each other. My video will be up on Odyssey and YouTube and BitChute and BitTube as well. So you can watch it there post ad nauseam. I don't know, whatever. All right.